Over the past few months, astronomers have been observing several surprising developments, both inside and just beyond our solar system. Some of these discoveries are small but meaningful, like a newly found moon quietly orbiting Uranus. Others are much more dramatic, such as an interstellar comet visiting from another star. And far beyond Neptune, a mysterious object with a bizarre orbit is challenging our ideas about how the solar system evolved. Even after decades of telescopic surveys and multiple deep space missions, the space around us continues to reveal new and sometimes unexpected phenomena. These discoveries remind us that exploration is far from finished, and that many mysteries still exist in places we once assumed to be well understood. Let's begin with one of the most intriguing new arrivals, the interstellar comet 3I Atlas. It was detected in July 2025 by the Atlas survey, a planetary defense system designed to track asteroids and potential impact threats. Its trajectory was unusual from the very first observations. Astronomers realized that the comet was not gravitationally bound to the Sun. Instead, its orbit was hyperbolic, meaning it came from interstellar space and is already on its way back out again. Only 2 other such objects have ever been confirmed: 1I Oumuamua in 2017 and 2I Borisov in 2019. Each of them showed completely different behavior. So, when another interstellar visitor appeared, scientists reacted quickly. Telescopes around the world, including the Gemini South Telescope, began observing the comet almost immediately. It was already active at a distance of more than 6 astronomical units from the Sun, which is unusually far. Most comets stay frozen until they're much closer to the heat of our star. But 3I Atlas began releasing gas and dust early, revealing that its chemical makeup is not like most comets formed in our own system. Detailed spectroscopic studies detected an exceptionally high ratio of carbon dioxide compared to water, roughly 8 times more CO2 than H2O. This suggests that 3I Atlas may have formed in a region extremely rich in carbon compounds, possibly far beyond the snow lines of its original planetary system. The Hubble Space Telescope managed to estimate the nucleus size to no more than 5 kilometers, possibly even smaller. Radar measurements helped track its increasing speed as it continues to accelerate away from the solar system. And even though some early theories proposed artificial origins, especially after Oumuamua's strange behavior, current data shows that 3I Atlas behaves perfectly consistently with a natural comet. Still, interstellar comets are incredibly valuable. They carry unaltered materials from other star systems. Studying them lets scientists directly sample the building blocks of planets beyond the solar system, something we cannot yet do with probes or landers. Now let's return to our immediate cosmic neighborhood, Uranus. The ice giant has always been one of the most mysterious planets in our system. It rotates sideways, its magnetic field is strangely tilted, and it remains one of the least explored worlds, as only one spacecraft, Voyager 2, has ever flown past it. So any new discovery there is exciting. In August 2025, the James Webb Space Telescope detected a previously unknown moon orbiting Uranus. It is currently designated S-2025-U1. The moon appears incredibly dark and small, only around 10 kilometers in diameter, which explains why earlier missions and telescopes missed it. It reflects so little sunlight that Webb needed its high sensitivity in the infrared spectrum to notice it. It orbits between 2 other moons, Ophelia and Bianca, and completes each orbit in under 10 hours. Researchers suggest that this moon, like others nearby, probably formed from fragments of a much larger moon that was torn apart long ago by gravitational forces. More importantly, its existence hints at the possibility of other tiny moons hiding within the complex rings of Uranus. Future missions to Uranus, which NASA and ESA are currently evaluating, could reveal many more. But for our next story, we head far beyond Uranus and Neptune, into the dark and distant realm where sunlight is faint and the solar system fades into interstellar space. In 2023, astronomers using the Subaru telescope identified a new trans-Neptunian object, designated 2023 KQ-14, informally known as Ammonite. Follow-up observations confirmed that it belongs to a rare group of objects called sednoids. These are icy bodies that orbit the Sun at extreme distances, too far to be influenced significantly by Neptune's gravity. The first of these, Sedna, was such a surprise discovery in 2003 that astronomers immediately began questioning whether something massive was lurking in the outer solar system. Ammonite's orbit is even stranger. Its path is extremely elongated and tilted at an angle not shared by the others. This throws a curveball into the leading explanation for sednoids, the Planet 9 hypothesis. This hypothetical planet, much larger than Earth, was proposed to explain why many distant objects seem to cluster in a specific region of the sky. But Ammonite doesn't match that pattern. Some scientists now think this means the outer solar system could be influenced by multiple smaller masses instead of one large planet. Others suggest that interactions with passing stars early in the solar system's history might have scattered objects like Ammonite into their strange orbits. Or maybe the data set is still too small. Perhaps we're just seeing the first pieces of a much bigger puzzle. What all of these discoveries tell us is that our solar system remains dynamic, complicated, and filled with unanswered questions. The interstellar comet 3I Atlas reminds us that planetary systems interact with each other. Their debris travels across the galaxy. The tiny moon S 2025 U1 shows that exploration of the planets we already know is still incomplete, even after centuries of observation. And the distant object Ammonite challenges our models of how the solar system formed and what influences shaped it. We often think of astronomy as a science of giant discoveries, landings on planets, huge telescopes, new galaxies revealed. But sometimes the most important progress comes from finding something small. A dark moon only 10 kilometers wide, a comet nucleus only a few kilometers across, or a distant speck of ice slowly orbiting in the dark. Each one adds another clue, another piece in the enormous cosmic puzzle, and as long as our instruments keep improving, we'll keep discovering that the universe still has a lot to show us.